Assalamualaikum and good day, dear student. So now let's discuss together in details example HEUN method. Okay, so now let's look at this example. So you asked to estimate the initial value problem for the given dy dx equal to exponent negative 4x minus 2x plus y, where x is between 0 and 2. And then given here is the initial conditions. Okay, so it means that x not equal to 0, your y not equal to 1.0. So you're asked to use RK2 with HEUN methods. Okay, and given also the step size or delta x equal to 0.5. So to facilitate you, okay, so I put here the formula for HEUN methods. Okay, so you may refer here to this formula here in order to helps you to memorize or to look again, okay, what is actually the formula for HEUN method step by step. Okay, so let's solve this together. Alright, so you are given y prime. Okay, so y prime is actually our fxy. Okay, is equal to exponent negative 4x minus 2x plus y. Okay, so since we have the x between 0 and 2, and we also have the step size delta x equal to h equal to 0.5. So if we draw our timeline, okay, in order to give us the idea how many solutions that we need to obtain or calculate, alright. So here is your x naught equal to 0, and then your x1. So this is your step size, h equal to 0.5. So as we know that x1 is actually equal to x0 plus your step size. So 0 plus with your 0.5. So the next x1 is actually 0.5. So the step size is equidistant. So x1 is a 0.5. And then we have our x2 1.0. And then x3 1.5, and then the last one is so here is your x4 equal to 2.0. so you only need to calculate until x equal to 2. Alright, so here is at x not equal to 0, this is our y naught. So y naught is actually come from your initial condition, okay, this one. So it's equal to 1.0. Alright, but the question is, this is our task. Okay, we need to calculate what is our y1, what is the value for y2, y3, and also y4. Okay, so we will calculate this by using HEUN methods. Okay, so this is RK2. Alright, so you may refer here to the formula. Okay, so let's start our calculation. The first one, I equal to 0. So we will approximate the value for y1, okay, by using HEUN methods. y1 is obtained from y0 plus the average of K1 plus with K2, okay, and then multiply with our step size. Alright, where K1 is a calculation of fx0, your slope at fx0 and y0. So here is x0 is 0, y0 is 1. Okay, so you substitute into the fxy here. So we have exponent negative 4, 0, minus 2 times 0, and then plus with 1. So you may obtain K1 equal to 2. Alright. So for second slope K2 is calculation for your f at the point x0 plus h and y0 plus k1 times with h. Alright. So this is actually 0 plus 0.5, and then at this point is 1 plus 2 times with 0.5. Okay, so if we simplify here, so we want to calculate the slope at the point 0.5 and also 2. Okay, so substitute into the equation. So we have exponent -4 times with 0.5, and then minus 2 times with 0.5, and then plus with your y2. So you may obtain K2 equal to 1.1353 if I set my calculator in 4 decimal places. Alright, student. So therefore from here, we may obtain our y1 equal to y0, 1 plus the average of k1 plus k2, 2 plus 1.1353, and then multiply with your step size 0.5. So you should get y1 equal to 1.783. Okay, so this is our y1. Okay, next we continue for I equal to 1. Now we want to obtain the value for our y2. Okay, by using HEUN method, it's come from y1 plus the average of two slope k1 plus k2 times with the step size. Okay, so where the first slope is come from f at the point of x1 and y1. Okay, so x1 now is 0.5. y1 from the previous calculation 1.7838. Then you substitute into the equation exponent -4 times with 0.5 minus 2 times with 0.5 plus with your y 1.7838. So you may obtain K1 equal to 0.9191. Alright. So now we calculate our second slope K2. K2 now is the calculation of f at the point, okay, x1 plus h and also y1 plus k1 times with your step size. Alright, so if we simplify this, it's a point of 1 and also 2.2434. Okay, then substitute into the equation exponent -4 times with 1.0 minus 2 times with 1.0 and then plus with your y 2.2434. Okay, so therefore you may obtain your K2 equal to 0.2617. Alright. So now we can calculate, we can approximate our second solution y2. Okay, where y2 is equal to y1 from the previous calculation 1.7838, and then plus the average of our two slope, okay, k1 plus k2, and then we multiply with our step size 0.5. Okay, so if you calculate this and simplify, you may get y2 equal to 2.0790. So this is your y2. Okay, we still have y3 and y4. Okay, so next calculate when I equal to 2. So we want to obtain our y3. Okay, y3 by using HEUN methods, it's come from y2 plus the average of two slope time with our step size. Alright, where the first slope is now is the calculation for our f at the point x2, y2. Alright, so if we substitute, x2 is 1.5, and then, x2 is 1.0, okay, 1.0, and then y2 from previous calculation is 2.0790. Okay, so substitute into equation, exponent negative 4 times with 1.0 minus 2 times with 1.0, and then plus with 2.0790. So you may obtain your K1 is equal to 0.0973. Okay, so next calculate your second slope, K2. So this time, K2 is at the point x2 plus h, and also y2 plus K1 times with step size. Okay, so if we substitute the value 1.5, and here is a 2.1277. Okay, so insert these two values into your slope or first derivative equation. Is the exponent negative 4 times with your x, and then minus 2 times with your x, and then plus with your y, 2.1277. Okay, so from here you may get your K2 equal to negative 0.8698. Alright. So now from here we may obtain our y3. So y3 equal to y2, 2.0790, and then plus the average of two slope, K1 and K2. Okay, time with your step size 0.5. Alright, so if you calculate this, you may get 1.8859. Okay, so now we left with the last one. When I equal to 3, by using HEUN method, we may calculate our y4 from the value of y3 plus the average of two slope. Okay, time with step size, where the first slope is come from the f as the point x3, y3. Okay, so x3 is 1.5, y3 from your previous calculation 1.8859. Okay, so substitute into the y prime or first derivative, exponent negative 4 times with your x, minus 2 times with your x, and then plus with your y. Alright, so if you calculate this, you may get your K1 equal to negative 1.1116. Okay, then for second slope, K2. So K2 is come from our f at the point x3 plus with h, and then here is y3 plus your first slope time with your step size. Okay, so if you simplify this, you may get 2, and here is 1.3301. And then now we substitute into the equation, exponent negative 4 times with x, minus 2 times with x, and then plus with our y, 1.3301. So if you calculate this, you may get your second slope is negative 2.6696. Okay, so therefore from here we may get our y4 is equal to y3. So y3 is 1.8859, and then plus with the average of K1 plus with K2. And then you multiply with your step size. Okay, remember this is HEUN formula. And then you may get your y4 is 0.0973. 4.9406. Okay students, so if I summarize in the table, so this is all the values that we obtain, okay, by using HEUN methods. Alright, therefore I can make a conclusion. Okay, so therefore we can conclude that the approximate solutions of our initial value problems are, okay, so we know that at x not equal to 0, this is simply is our y not equal to 1.0. And then for y equal to 0.5, we obtain by using the HEUN methods is given by our y1. Okay, so y1 is a 1.7838. Okay, so you may refer here. Okay, this is what we get from HEUN method, the approximate solution by using HEUN methods. And then y when x is 1.0 is approximated by our y2, which is 2.0790. And then y when x is 1.5 is approximated by y3, okay, which is 1.8859. And then the last one, okay, at the end point when x equal to 2.0 is the approximated by y4, okay, so given by 0.9406. Okay students, if you may look here at this figure here, okay, so this is the comparison I plot. If I have the exact solution, okay, I do not show the details solution of exact, but I'm just showing you in terms of graphical illustration. So the black curve here is the exact solution. Okay, you may refer here exact, Euler and HEUN. The red curve here is represented by Euler's solution. So the blue curve here is the values that we obtain by using HEUN method. So you may see that in terms of accuracy, HEUN method is much better compared to Euler methods. Okay, because it's closer to exact solution. Alright, so that's why RK2 improve the approximate solution obtained by the Euler methods. Okay, so I stop here. So next we will discuss on midpoint method. Thank you for your attention.